In this video, we'll discuss how to name and write formulas for molecular compounds. Remember that ionic compounds and molecular compounds are different, where ionic compounds have ionic bonds, and those are between metals and nonmetals, where molecular compounds have covalent bonds between nonmetals or metalloids and nonmetals. Now, with covalent bonds, that's just the sharing of electrons between atoms. And if you notice in these examples, with water, you have oxygen and hydrogen. There's a bond here. They're sharing electrons. These two atoms are sharing electrons. But then you have the same thing here with oxygen and hydrogen. There's another covalent bond where they're being shared. And you notice with ammonia, you have the same thing, but you have three nitrogen-hydrogen bonds. In each case, they're sharing the electrons. So when it comes to naming, you have to be able to look at the formula first to be able to name. And so you look at the elements and you list them in order that you see in the formula. So in the case of nitrogen monoxide, we have NO, so that's N is first, oxygen is next, so we would name it in that order too, nitrogen monoxide. You have to use the Greek prefixes in the name. So if there's one element, it's mono. If there's two, it's di. 3 is tri. 4 is tetra. 5 is penta. Hexa, hepta, octa, nona, deca. In this example, you may have noticed that I have a Greek prefix for the second element for oxygen, but I don't have a Greek prefix for the nitrogen. And the reason for that is because in this formula, notice how there's only one nitrogen. So if the first element in that formula, there's only one of them, like you see right here, we drop the mono. We don't include the mono in that name. So it would be nitrogen monoxide. Mono because there's one oxygen. If the prefix ends with A or O and the element begins with A or O, the final vowel sound is dropped. So that's why we didn't say monoxide. It would just be monoxide. In the next example, we have N2, that means there's two nitrogens, O7, 7 oxygens. So dinitrogen, because 2 is di, the element is nitrogen, dinitrogen, and then the other one is heptoxide. 7 is hepta, so 7 oxygens is heptoxide. You may have noticed that we changed the ending to "ide" each time, so we have to change the second element. We change the ending to "ide." Here's some examples. N2O4, dinitrogen tetroxide. N2O3, 2 nitrogens, that's dinitrogen trioxide. NO, nitrogen monoxide. N2O5, dinitrogen pentoxide. Now, doing formulas, it's the same thing, but in reverse. So you have to look at the name, you write the symbol for each, and then use the Greek prefix to determine the subscript. So sulfur hexafluoride is S. Remember, it doesn't say mono because it's the first element and there's only one of them, so it's just sulfur. It would be just one S, and then hexafluoride would be 6 for hexa, and then fluoride is for fluorine. In the next example, tetraphosphorus nonasulfide. Tetra, phosphorus, 4 phosphorus, and then nona is 9, so 9 sulfur. Tetraphosphorus nonasulfide, P4S9. Carbon monoxide, that's carbon, and then one oxygen, mono is 1. Remember, carbon doesn't get the prefix because it's the first element and there's only one. Carbon tetrachloride, carbon tetrachloride. Carbon dioxide, carbon di for 2, oxide. And then dichlorine monoxide. 2 is di, dichlorine monoxide.